Hello, today I'm going to be taking you through another lab simulation of an experiment. The experiment we're looking at today deals with reaction rates and what factors can affect them, either increasing the reaction rate or decreasing the reaction rate. Alright, so let's get into it. This is our lab simulation here, and I'm just going to explain the reaction we're looking at, and then we can get into seeing what happens. So the reaction we're looking at is A plus BC is going to be forming A, B, and C, which is going to be important. And so this is the space that the reaction will take place in. As you can see, the temperature notch right there. And this is going to be where we see how much we're starting out of, and it's going to show the current amounts of each. So we can see these ones decrease and these ones increase and see how fast that's happening. And this one's just showing the average energy of all of the molecules in comparison to the activation energy and potential energy. So right now we're going to start an experiment at 50 of each type of reactant and see what happens. And we're going to keep everything the same because this is going to be our standard reaction. You can actually show up here. As you can see the molecules, the reactants, and we'll start to see some of the reactants form. So right now we kind of started out at a cold temperature, so going to be a slow reaction rate, which we can see that happening already. So they're slowly forming. Now, what we can do to increase this reaction rate is one of many things. First, we're going to start out by increasing the temperature. And what increasing the temperature is going to do is it's going to increase the average energy of all of the molecules, meaning that more of the molecules are going to have the required activation energy in order to react and thus progress with the reaction forming the products. And we'll be able to see that happen right now. So I'm going to raise the temperature all the way. And we can see it already going up on our notch. So they're starting to move, and our average energy should be climbing. Oh, actually. Oh, I guess I have to hold it there. Should be climbing, and we will see that our products will start to form much faster, which is happening right now. You can see the numbers are actually decreasing and increasing a lot faster. Alright, so now we're going to let go of that. Let that go back down, and there's other things that we can do in order to increase. So I have to reset this. And we're going to add more of our starting reactant. So we're going to go 100 and 100. Now what this does, it's going to increase our molarity because we're going to have more moles of the reactants in the same amount of solution. So this shows how this is a higher molarity because you have the same amount of moles in a smaller amount of solution. This has the same amount of moles in a larger solution. So we'll see what this does. Can begin it. Alright, so as you can see, we have a lot of molecules in there, and because we have a lot more molecules in the same amount of space, then there's going to be a lot more collisions, and so the chances that a collision works and has the amount of activation energy is going to increase. Therefore, the reaction rate is going to increase due to the increased molarity, which we can see happening right there. Alright, can end that experiment. And I think the only other thing I wanted to touch on is what would happen if you used a catalyst. So now what a catalyst does is it's not really a reactant or a product, but it's going to lower the activation necessary for the reaction to take place, meaning that more molecules and more collisions will happen because there's a lower activation energy. Alright, I hope this helps.